All right, so 1, 4 goes beyond quadratics. That's what the idea behind polynomial functions and rates of change are. First of all, these graphs all have continuous graphs. So when you're graphing one of these polynomials, they are also called polynomials of higher degree. That's like a common term for them. These are, the poly means many, okay, or much. A non-constant polynomial, so this is no longer a straight line, is a function with many terms in this long form. This form looks like a foreign language, I understand, but I'll explain it, okay? It is basically saying, yeah. It is saying that it is f of x equals, and the n is going to be the highest exponent. Yeah. All right, so it will say something obviously like f of x equals, and then there's going to be, everywhere you see an a, okay, or an n in this little thing, there would be a coefficient or an exponent. And the way, so a couple things from here. One is n has to be a positive integer. So all of these exponents would be positive integers, okay? A sub 1 is a real number, which means these are all real numbers. There's no i's in here, okay? And the highest exponent is our n. So if I look at this one is in order. It doesn't have to be in order, okay? If it's not in order, you would rearrange it so it is in order, okay? But then the highest exponent is your n, and this is called the degree of the polynomial, which we're going to get to in a little bit. But again, these are continuous graphs, okay? That means that they are one solid line. It doesn't have to, it can go up, it can go down, it can come up again however many times, but it is one fluid line, which means there are no piecewise functions in here. There's no sharp edges, okay? They look like these. So on the left are what they could look like, and on the right is what they cannot look like. So these are not graphs of polynomial functions. This one's piecewise, okay? This sharp corner will not happen in the things that we are about to graph. They will be fluid, okay? They can go up, down, as many times, but they will be one fluid line, okay? They can have at most n minus 1 turning points. And n is what again? Highest exponent. So if the highest exponent is 5, the most amount of turning points they can have is 4. They can have less than that because we're going to talk about non-real roots in a little bit. But they can't have more, that they can't have n or more than n. One less than it is what they are able to have, okay? Example 1 literally says, what's the leading term, what's the degree of the polynomial, and what's the leading coefficient? So 3 parts here. The very first thing you have to do is find the one with the highest exponent, okay? You can reorder this, but you don't need to yet. The one with the highest exponent is negative 3x to the 7th. That is your leading term. What is the degree of the polynomial? 7, highest exponent. And what is the leading coefficient? Negative 3. The sign goes with it. So it's the number on the front of the one with the highest exponent. Spoiler alert, that is not a test question. Yeah. All right. The next thing you're going to learn to read from your graph is called local extrema or extrema, okay? This is the same thing as a relative max or min. So in chapter whatever in the textbook it says relative max or min. We are now going to call it local extrema. A local max occurs anytime the graph changes from increasing to decreasing. A local min occurs anytime the graph changes from decreasing to increasing. You can have multiple local or relative extrema. And an included endpoint of a polynomial with a restricted domain may also have a local relative extrema. And what that means is it doesn't have to come back up for it to count as a relative extrema. So this point here, where it ends there, it has to have a solid dot, like not an arrow, but that ending point will count as a local or a local max, okay? So this graph will have a local max there, it will have a local max here, and it will have a local min here. Yeah.
We have 2 max because it doesn't like continue. Like it doesn't have an arrow showing that like.
Correct. If this was an arrow, there would only be one local max. It would be the other one. So it has to end there.
What's the difference between this and the other?
It's just that they call it local extrema instead of, it's the exact same thing. Relative maximum are the same exact thing. It's just the wording that changes. Yeah.
Does it have to have at least one arrow, or can they both be like endpoints?
They can both be endpoints.
So those would both be
Yeah, it could end up. They could be like here, here. Actually, it wouldn't be so sharp though. It would be like here, here, here. It could end like that. So there would be a max, a max, a max, and a min, and a min. Yep.
If you had a straight line, how would you calculate? Or that wouldn't happen.
It wouldn't have either.
Okay.
Arrows on both sides, you're saying? So even a cubic function
No, like what if it's just like
has neither.
like y equals.
If it's horizontal, so these are non-constant. Like it can't be horizontal. It can't be a horizontal line because your exponent is not higher than, it has to be 2 or higher.
Okay.
Yeah. All right, a global is the same thing as an absolute max or min. So the word global replaces absolute. The global extrema means it only happens once. It is either the highest point or it is the lowest point. You cannot have more than one. Again, that's the difference. Global is the same thing as absolute, except it won't say absolute anymore. It will say global. And again, there can be only one max. There can be one max and one min, but there can only be one of each. Or there can just be one max. Or there can just be one min. Yep.
What if it's like an M graph?
It would have to go curvy, right? And one would have to go bigger than the other for it to be considered an absolute max. So it would have to go down like that. So the absolute would be this one. If they are both the same, there is no absolute. Watch the format on these because it will say sometimes where the max is or the min is, and that means give me the y value. But then it will also say it occurs at x equals, and now it wants the x value. So you'll see it in an example. But watch how it's asking for the question. If it wants just the min or just the max, it's the y coordinate of that max or min.
Can you say what you just did?
He said, what if it was like an M-ish shaped graph? It would have to have one that is raised higher than the other. This would be an absolute.
So what would the other one be?
That would be a relative or a local,
It's the highest.
because both of those are considered to be local, but absolute is only the highest or only the lowest. There is no absolute minimum on this one. There is a local because it comes down and goes back up again. That would be a local one, but there is no global or absolute one. All right, so again, pay attention to the wording here, okay? Use the diagram to answer the questions. A, find the absolute min of, so that blank means give me the y of the absolute min, and when x is, give me the x that corresponds to the absolute min. So if you're looking at this graph, where's the absolute min?
3.
Trick question. Where's the absolute min?
7? It's not defined or something?
It doesn't exist because this arrow is going to keep coming down. There's no way for you to find the absolute min. Okay? So if that happens, you literally could put NA, you could put DNE. I don't care what you put there. But it does not exist, and that kind of question can come up. Yeah?
What do you put in the blank? Like, do you put the y, the absolute?
For the absolute min, it would be the y. When x is, would be the x. Yep. So where is the absolute max on this graph, Edward?
7.
This coordinate point here, which is 0, 7, the max part of it is 7, which is the y coordinate of that. And when does it occur at x equals? 0. Good. Now, relative mins, and look what it says. The relative mins are at x equals. So I'm looking for the x coordinate of all of my relative mins. So I'm going to identify the relative mins first. It goes down and comes back up here. That would be a relative min. Is there another time it goes down and comes back up? No. So my relative min is at that coordinate point, which is negative 3, 3. If it asks for the value, it would be 3, but it's asking at the x, which is negative 3. And then it asks for my relative max. Where is my relative max? At negative 6 is 1, and 0 is the other. Negative 6, 6, and 0, 7. And again, it wants to know what the x is where those are occurring, which would be negative 6 and 0. Yep.
If a graph is given on the test, would I have to like mark it, or can I just like?
No, you could just, I'm just marking it so you can see it. You don't have to mark it on that graph. Questions? All right, extrema between zeros. So the rule is if you have two zeros of a non-constant polynomial, so we're saying not a horizontal line, if we have two zeros, then there must be at least one local extremum between them, which means one local max or one local min. And this is why this is happening, okay? Let's say these two are my zeros. My graph can either start down, it can start here, come up, come back down like that, and I would have how many local, what kind of local, max or min? Max. You'd have one local max. If I go the other, well, in that way, you'd actually have an absolute and a local. Yeah, but this is just saying at least one local. If it comes down and goes back up again, now I have a local and absolute min, right? What if it bounces, if you remember this? If it bounces off this point, it has to come back up at some point. Now, I still have one local min here. If it bounces the other direction, I have to come back down. I still have one local max. The other thing it could do is bounce off both. It could bounce, come up, bounce, come up. But it cannot cross in between those because we're saying that in between those two, right? So nothing else can happen there? Yep. No, that would be a third zero. So that's a good question. This just happened. Like, what if it does this? That brings in an extra zero. You can't bring in an extra zero. So it cannot cross in between. So no matter how many of the different options we try within those two, okay, there must be at least one local extrema between them.
Wait, you said it can't cross zero?
If you're bringing in another zero. Now you're bringing in another zero. We're testing these two zeros. So in between these two, it can come up, come back down, come back up again, right? But in between each pair, we're saying it has to at least have one. It can have more, but we're saying it has to at least have one. Okay. So that kind of question will show up. Yep.
Oh, can you go like back?
I'm gonna reread this because I wasn't recording. Let f of x be a polynomial function with the given values. Are there any guaranteed extrema? And if so, state where they occur. So think about what these pieces of information are really disguising. How can I rewrite this that it would make sense on a graph? What would be the coordinate point? 0, negative 1. What would be this one? 1, 0. What would be this one? Negative 3, 0. So what kinds of points are these? X, or there's even a y there, right? How do I know which one's the x-intercept? The one that has the y of 0. So this is really saying 1, 0, and oops, negative 3, 0. Let me go the other way. And then the other one is your y-intercept, 0, negative 1. My rule said nothing about y-intercepts, right? My rule said in between each pair of zeros, what happens? You have to have at least one extrema. So where are we guaranteed to have one or more than one extrema? Between, say it again. Between negative 3 and 1. So we're back to interval notation, folks. From negative 3 to 1, there will be, you're guaranteed at least one extrema. Yep.
It's like in between the x-axis, right?
In between the zeros.
Okay.
So if there was another 0 over here, I'd be guaranteed to have one in between these two. So the trick here really, the way that they'll I don't even know how these get tricky, is by throwing in other points. Just look for your x-intercepts. Those are your zeros.
But if you had the other 0 there, you would have 2 places where there would be a guaranteed.
Correct.
Thank you.
You're welcome. All right, even degree and absolute extrema. This says if the polynomial has an even degree, so we're talking something like x squared or x to the 4th or x to the 6th. That's what it means by even degree. There is either an absolute max or an absolute min. There cannot be both. If it's a positive leading coefficient, it means you'll have an absolute min. If it is a negative leading coefficient, it means you'll have an absolute max.
It's just like a parabola, right?
Could be, but it could take on a weird shape in between. Yeah. Edward?
What if it has like a restriction? Would it then have?
It won't happen for here. They won't, because that's not a continuous graph. So there won't be a restriction on these. That's like a piecewise function. These are not piecewise functions. So if you go back to the polynomial in the beginning, it said that's continuous. So there would be no breaks like that. All right, so it says positive leading coefficient. So if it is an x to the 4th with a positive number on the front, this means it's going to open up, okay? Both of those ends are pointing up. I'm not saying exactly what's happening in between there, okay? But at least we'll have one absolute min. If it was an x to the 6th, let's say, and it's negative, now it's opening down, there will be one absolute max. This rule only works for evens. So if it says something about an odd exponent, we know nothing about absolute maxes or mins if it's an odd exponent. Only if it's got an x to the 4th or an x to the 6th.
Do they mean leading or just in general?
Leading, so whichever one is in there, that's the biggest. Leading doesn't have to be first, but biggest.
Okay.
Yes. Degree always refers to biggest. So it says even degree, it's saying the biggest exponent has to be even.
Okay.
Yep. All right, so example 4, is there an absolute max or min for each function? What are we looking for? Positive and even or negative and even, okay? So if you look at A, is the highest exponent even? Yes. What's on the front, positive or negative? Which means? Min. Okay, you can put absolute min, but that's what minimum is what you're looking at, okay? B, highest exponent. Can we determine anything about a max and min right now? Nope. So no, there's not an absolute min or max. Or actually, I think it says can't be determined. Something like that. Not enough. No, yeah, can't be. And then C, highest exponent is 4, which is even. Sign on the front, which means there's an absolute max. Good so far? All right, point of inflection. And we talked about this last week when we talked about concave up and concave down, okay? But we didn't see it in print yet. The point of inflection occurs at the input values, or the x values, where the rate of change changes from increasing to decreasing or vice versa. This occurs when the graph changes from concave up to concave down. So if I have a graph and it changes from concave up to concave down or concave down to concave up, then the point of inflection is where it changes. So if this part of my graph, the first part of my graph is called what? Concave down. And the second part of my graph is concave up. So the point where they meet, that would be your point of inflection. Oops. Notice it's not from where the graph is increasing and decreasing. It's from where the rate of change on the graph is increasing and decreasing. Remember, those are two different things. Okay, rate of change is your concave up and concave down. All right, 5, identify the points of inflection. So this whole thing here is concave down. This whole thing here is concave up, which means my point of inflection is 2.33 and 8.29.
Points of inflection can never be a max and min, right?
Correct. I don't know if I heard that, but a point of inflection can never be a max and min. No, it cannot. Good so far. I pulled up the homework for last night. Questions on these? How'd we do? Bad?
Bad. I got the first one right. I was like, okay, and then I got the rest of it wrong.
All right, let's talk about one then. Did we do bad on one?
No.
Okay.
I don't know.
All right, 1 said the table gives the values of the function. If you want to open it up, if you don't know your correct and incorrect answers, if you want to open up, you can. The table gives the values of the function for the selected values of x. If the function f is linear, what's the value of f of 13? So we found, or I found, the rate of change or our slope to be 4/3. And this time they didn't give you a b. So yesterday we talked about what would happen if I didn't give you the b. You'd have to grab any of those points. I use 6,2 because they're both positive and I don't want to make a stupid mistake on a negative. So I grabbed 6,2 as my point and 4/3 as my slope. And I actually plugged it into y equals mx plus b, but you could have also plugged it into point slope. I found that b was -6, and then I created the linear function, y equals 4/3 x minus 6, and then I found f of 13 by plugging 13 in, which was 34/3. Questions on that one? All right, 2, these kind of got weird just because of the terminology, right? So 2 said, the function f is defined for all real values of x for a constant a. The average rate of change of x from x equals a to x equals a plus 1, so that means from one term to the next, only increasing by 1, is given by the expression 2a plus 1. Which of the following statements is true? Because that was not a constant, I knew this has to be a parabola, okay? If you're talking about the rate of change from the first one to the next one, it would just have slope. This has slope plus something. So that's how I ruled out that it had to be at least a parabola. And then it said the average rate of change over the consecutive equal length input intervals is increasing at a constant rate. So every time this was increasing by the same rate. So if the rate of change was increasing by the same rate, now you're talking about that parabola. Yeah. Because the rate of change of the line would be the same, so this is saying the rate of change of the rate of change. It's already giving you that interval. This means it's changing every time. If it was a line, it would just be a constant. It would be the same number every time.
So it would just be x
2,
equals-
3, 2/3, 1/4, right? Because that's what you're changing every time. If it's a line, there's no variable change there. It's the exact same change every time. Does that make sense? Okay. And then it was increasing because it's 2x or 2a plus 1. So it's an increasing. It would increase every time. Yeah.
Are questions like these going to be on a test?
So, eventually, yes, but not yet would be the answer. When we start to do our cumulative testing to prep for your exam, we're talking, this is a March problem, technically, but the more you see them, the more they're going to start to make sense, hopefully. That's the hope. All right, 3 says the average rate of change of the quadratic function p is -4 on the interval from 0 to 2, and then from -1, and then -1 on the interval from 2 to 4. What's the average rate of change p on the interval of 6 to 8? So the rate of change is going to be the same, right? So if I go from -4 to -1, I'm going up 3. The trick here was what? How'd they get you? Instead of just adding 3 and making my answer 2, what was the catch there? It skipped an interval. The last interval they gave you was from 2 to 4, and then it wanted the interval from 6 to 8. So you had to do it twice. So from 2 to 4, then there was one from 4 to 6, which was 3 higher. Then there was one from 6 to 8, which was 3 higher. That's why it skipped.
So what are we doing? So what do we have to do?
So you're adding the rate of change to get to the next one, but it is that rate of change for every interval. And so from 0 to 2, it was negative 4. Then from 2 to 4, it was negative 1. So the rate of change there was positive 3. Now I needed to add positive 3, but that gave me the next interval, which was 3 to 6. It wanted the one after that, so I had to add 3 again.
Oh, okay.
Yeah. If it just said 4 to 6, then it would have been 2. Okay, and then I remember this question. An object is moving in a straight line from a starting point. The distance in meters from the starting point selected time is given in the table above. The pattern is consistent. Which of the following statements about the rate of change over the distance is true? So first of all, this was not an over 1 scenario because these were different, right? So we had to find the rate of change. 9 minus 1 over 3 minus 2, or 8 over 2, which was 4. No, this should be, that should be 1, which was 4. And then I did it from the next one, 21 minus 9 over 6 minus 3, which was 12 over 3, which was 4. And then 41 minus 21 over 11 minus 6, which is 20 over 5, which is 4. So the first level of change was the same, which means this is linear, okay? And it said the rate of change of the rate of change. So if I went one step further, the change would have been 0. So it's not just the rate of change. It's asking for, if you look in your choices, it's the rate of change of the rates of change. So it was 2 levels, okay? So if it just said rate of change, then it would have been 4. But because it said rate of change of the rates of change, we had to go one more level, which would have been 0. And if it's 0, that means it's not changing. It's not speeding up or speeding down. Yep.
If we know it's a line, we can already cross out C and D.
Yeah.
Okay.
Yeah. Yeah.
How did you know it was meters per second per second?
So every rate of change adds another level. So like the first rate of change is meters per second. The next rate of change would be meters per second because you're adding an extra one. Okay. So if I just did one rate of change, it'd be meters per second. But then you're doing the rate of change of that. So you're doing the meters per second of the meters per second.
Okay.
Yeah. Okay, I hate these cups. They're going to be the death of me.
Did it spill?
Yep, it's all over. We'll get it in a second. Yeah.
Oh, then in the cumulative stuff, would you put rate of change per second, or would you keep it as per second per second?
It would have to be per second per second. If it's a rate, if it's just rate of change, its rate of change would be just per second.
Okay.
It's because it's rate of change of rate of change that is per second per second. Okay, 5. The table of values is given. Which of the following conclusions with reason is consistent with the data in the table? Okay, if you found your first rate of change, this time you were going up by 1. So the first rate of change was -3, then -1, then 1. This was not consistent, otherwise it would be a line. The next level of it was -2 and -2. That means that it was quadratic. So I ruled out the linear and I went to the quadratic ones. And then if you look, if you actually plug in these values, y equals 2x plus 1, if I took -2, which is the work over here, and I made it 2 times -2 plus 1, I got -3. 2 times -1 plus 1, I got -1. So that's how I determined, okay, that it wasn't just the 2x. Yep.
Why is it -2 and not +2? Because that's kind of weird. -3 to 1, or -1 is kind of just 2.
Oh, no, it is +1. It is +1, but that doesn't, sorry. It is +1, but that doesn't change that it's not constant. It should be +2, sorry. All right, then the last one, and to me this one is the one that like threw most people because of the wording of it. Okay, the function, The function f is not explicitly given. The function g is given by g of x equals f of x plus 1 minus f of x. What does that mean? What would f of x be?
Negative?
We have no idea, actually, initially. But f of x would be what you, like if I had an equation, f of x is my first level, right? Those are my function values. So f of x plus 1 minus f of x would be what?
G of x?
Not value-wise.
Oh, shifted to like.
Not shifted. Think about what we did every time yesterday when we had a chart. Or even if we had an equation. First, we found f of x's. Yes, we found all the values. If it was f of 1 or whatever, we found the f of x. Then we found the other f of x. So if I wanted to, what is f of x plus 1 minus f of x? The rate of change of these values. So this was the next level. Yes? That's the rate of change. Let me explain it once, and then I'll see if I can explain it a different way. I'll go back. All right. Then h of x is g of x plus 1 minus g of x. What is that? The rates of change of the average rates of change. That's second level, right? So which of these must be true if that second level is negative 6?
All of it is decreasing.
It is G is decreasing. I don't know anything about H because H might be increasing or might be decreasing, but the rate of change on those is decreasing. And if the rate of change is decreasing, it's concave up or concave down?
How do you know if it's decreasing?
Concave down.
How do you know if it's decreasing?
Because the rate of change is negative 6.
It says it.
It gave you negative 6.
But like how,
But we're not reading it.
but like
tells
h
you.
of x isn't f of x.
H of x is the rate of change of the average rates of change. That's, you have to learn the, yeah. So like, okay, we know first of all, so here, I'm going to do it one more time. Hopefully this sticks. If not, I don't know, we'll worry about it later, I guess. Okay, if f of x is your original function, right, then all these values I would have plugged in or gotten from my graph, whatever, those would have been my initial values. Those are my actual y's. Then g of x was take this second one and subtract the first one from it. That's what that notation means, right? Take the next one, subtract the first one. Take the next one, subtract the one before. That's a rate of change, or an average rate of change. I should put the A. I don't know if I said it, but average rate of change. That means that's the f of x. No, g of x. Then it says h of x is the change of those guys, which means it is, wait, h of x. No, I was right the first time. Sorry. No. This is g of x. And then h of x is the rate of change of the average rates of change, which is negative, so it's decreasing, right? And if the average rate of change is decreasing, it's concave down. Does that make sense? Okay. The one I think that got people, it even got me for a second the other day, I was looking at it, was that it says like B looks pretty close. It is concave down, right? But what it says that's wrong is both G and F are concave down. I don't know the rate of change in here. If that was negative, then I can say that. But I don't know it. I just know the rate of change of that rate of change is negative. And that's why I can't make an assumption about F. Does that make sense? Yeah. Better? Okay.